session, we are welcoming Dr. Prasad Rao sir, who is a doctorate in mechanical engineering from Andhra University, Visakhapatnam, and he completed his master's degree in thermal engineering from JNTU Hyderabad with qualitative experience in operation and maintenance of thermal power plant, and he is a guest faculty of AP Genco Training Institute, Petroleum Refinery and Teaching. He is an effective communicator with honed analytical problem solving and organizational abilities. Sir worked as an assistant professor from GMRIT Rajaman System College of Engineering, Srikakulam, Andhra Pradesh, and he worked as a junior engineer, Hindustan Petroleum Corporation Limited, Visakhapatnam, and current he is working as assistant executive engineer in Dr. NTTPS Ibrahimpatnam of AP Genco Limited, Vijayawada, Andhra Pradesh, and such department was thermal power plant operation and maintenance, and his responsibilities are operation of thermal power plant from control room by coordinating with all divisions such as coal handling plant, DM plant, water treatment plant, fuel oil pump house, boiler, turbine, generator, transformers, ash handling systems, etc. And he maintained a mechanical equipment in coal handling plant, turbine, and its auxiliaries. Again, I will repeat, sir, he is a guest faculty of AP Genco Training Institute, Ibrahimpatnam. Sir, we welcoming you, sir, and I request our resource person to take over the session.
Sir,
సార్
అనిల్ సార్ కాల్ చేశాను, ఒకసారి జాయిన్ అవుతున్నారు, ఒక ఫోటో తీసుకుందాం సార్ ఒకటి.
ఓకే సార్, కెన్ ఐ కాల్ హిమ్?
సార్ జాయిన్ అయినాడు చూడండి ఒకసారి.
ఓకే సార్,
జస్ట్ ఒక 30 seconds ఒక స్క్రీన్ షాట్ తీసుకొని మనం దెన్ విల్ గో టు ద నెక్స్ట్ సెషన్.
I am back.
Anil sir, thank you sir. Just for 10 seconds we will take a snapshot, sir.
Sure.
Dear participants, please switch on our videos fastly.
Good evening, all of participants. Am I audible now?
yes
sir, you are audible, sir.
Okay, sir.
Very good.
Welcome to this wonderful session for sharing my knowledge, and I am very thankful to the Department of Mechanical Engineering, the Great College of Engineering, giving me this opportunity for sharing the knowledge. Today, actually, already my details are shared. I am Prasad Rao, working as Assistant Executive Engineer. Presently working in control room. Earlier I worked in turbine division mainly. Mostly I concentrate on overview of the thermal power plant and application of green hydrogen technology. What are the possibilities of applying this green hydrogen technology to the power plant, and what are the advantages and disadvantages? We briefly discuss later. So going to session, this is your plant overview. There are 6 10 megawatt power plants and one 500 megawatts and one 800 megawatt plant. And ఇప్పుడు వస్తుందండి presentation. కనిపిస్తుందా? Okay.
Yes, sir.
Sir, in this presentation, for PQ, view of the thermal power plant and hydrogen utilization in thermal power plant, where utilize the hydrogen and critical parameter of hydrogen and having the flammability percentages and methods of hydrogen production. We are generating hydrogen in our plant itself. And what is green hydrogen? Actually, we are not following this green hydrogen technology in our plant. We simply discuss what is green hydrogen and if we adopt this technology in this plant, what are the advantages and what are the challenges? These are the quick overview. I'm going to explain this total entire thermal power plant because we have learned so much regarding green hydrogen technology by so many guest lecturers who are experts in that area. So I am mainly concentrating on the thermal power plant and finally on the green hydrogen. So this is the total thermal power plant, which is a coal-based thermal plant. This total plant is divided into two parts: coal handling plant and main plant. In this coal handling plant, this is a fuel input to the boiler. Coal is the fuel input to the boiler. And after giving input, this heat energy is transferred to the turbine, where it converts heat energy into mechanical energy. Finally, we get the electrical energy. So we will discuss one by one slowly. I will go for CHP, which is a coal handling plant. This is the initial part of the plant. Here we get coal through the train. So after coming to the coal handling plant, these are the main equipment: wagon tippler, crusher house, stacker leg primers. These are the main equipment for unloading the coal and making the coal into small sizes. These are the main equipment of the coal handling plant. If you go to wagon tippler, the purpose of wagon tippler is to tipple. Tipple means they actually turn the one by one wagons into the belt conveyor. So those belt conveyors transfer coal from the tripling point to the crusher house. The next one is a crusher house. Generally, coal size is of 300 to 300 mm size. That 300 mm size is converted to 20 mm size in the crusher house. That crusher coal is sent to the bunker. Bunker is a temporary storage arrangement. I will show one by one. This is the main general layout of coal handling plant. Here, wagon tipplers come and unload in the hopper. So these come to the conveyors. These are all belt conveyors. These belt conveyors send the coal to the crusher, where it crushed into 20 into 20 mm size. These are the vibration scales. That means if any particle less than 20 mm size is there, those particles are directly bypassed and sent to the belt conveyor. After crushing her, these are sent to the bunker. These are some photographs of tripling. These are the dry level, and these wagons tilted here to 120 degrees. After tilting to 120 degrees, this coal falls onto the grid. This grid is of 300 mm size. So if any coal size more than 300 mm will stay here only. Below 300 mm fall down on the belt conveyor, and that conveyor to the crusher house. This is a crusher house arrangement. From the coal handling directly, it goes to the crusher house. This topmost point is the crusher house. So inside the crusher, this is the arrangement. These are all called hammers. These are called ring hammers. With the help of the ring hammer, this coal crushed into 20 mm particles. So a small video on this.
Today we will discuss about coal crusher, how coal crusher will work.
That is
There
I am
are
showing this video.
two crushers we have. in the gear arrangement. These are called crusher, and this is a crusher container in which our coal will be crushed. We will have a empty pan from which coal will be come into the crusher. There is a vibrator. When coal will come, small pieces of the coal from this vibrator will be collected and separated, and then goes to the directly to the chamber which we want to send the coal. So vibrator function is that to separate the small pieces of coal from the large pieces of coal. There is a magnetic separator. When coal will come, the ferrous particle or iron particle from the coal will be separated by the magnetic separator, and ferrous metal will be out from the help of magnetic separator, so that our crusher will not harm from the ferrous metal or iron metal. Then coal will go to the pan. Size will be coal of 25 mm to 200 mm, 25 to 200 mm, and which we want the coal crushed size less than 25 mm. When coal will be crushed, the size of the coal will be less than 25 mm. Now what will happen? Coal will come after the magnetic separator, and then these crusher will rotate and crush the coal, and our crushed coal will be directly go to the chamber which we want to move, or directly go to the power plant, and also vibrator separate the coal pieces will go and meet the this coal and go to the chamber here we want to send the coal. So this is the working of coal crusher for crushing the coal in the small pieces, so that we can use easily coal for our.
Okay, after crush the coal into 20 by 20 size, that's sent to the bunkers. These are called heavy equipment in the coal handling plant called stacker per bar reclaimer. That means it will stop the coal, and when the coal is received, and it can reclaim the coal when coal is deficient. That means it will store. There is a big yard storing the coal. If there is no requirement of the coal, that will be stored with the help of this equipment. In case of more requirement, the same point this equipment reclaims the coal. This is called stacker and reclaimer. These are the bunkers. From the coal that crusher house, coal directly from came up to this point. These conical shapes are called bunkers. These are temporary storage tanks, like a temporary storage tank. Below the crusher, there are mills. Mills are pulverizers. So after coal handling plant, this the coal directly comes up to mills. This is the mills or pulverizer. So here generally pulverizer mills are of two types: ball mills or ball mills. In 210 megawatts here in this Ibrahimpatnam plant, we are using both type mills. Unit 1 and 2 are using ball mill. Unit 6 are using ball mill. So ball mills are just like this. These are the inside parts of the ball mill. So coal is crushed in this gap between this roller, and it will the output of the crusher is 74 microns, like our face powder. This is the crush ball mill. So from the top of the ball mill, there are four lines. There are four lines from each mill. Each line goes to the each corner of the furnace. This is the furnace of boiler. So these are all bowl. From each mill, there is one line. It goes to each corner. Okay. So each mill supplies one elevation. One elevation, one by one, there are
Yeah.
6 elevations.
పనులు కూడా చేయమని చెప్పానన్న
Pardon?
ఇంకా ఉంది అనుకోకుండా ఇల్లు ఉండని చెప్పాను
నువ్వు అనకూడదు నేనే అనాలి.
ఏంటంటే
పంపించు.
మా అబ్బాయి
Next one is of ball mill.
Sir, excuse me, sir.
Tell.
A small request from participants, sir.
Tell.
Can you hide that?
Which
At side you have hide button underlined. You click that, sir.
Okay. Okay, sir.
Okay, sir.
Okay. Next one is a ball mill. So in this ball tube mills, there are three sizes of balls: 30, 40, 50 mm size balls. All are placed in a container, cylindrical container. The container rotates at 15 rpm horizontal axis. Due to this impact and friction method, 20 mm coal particle is crushed into 74 grams. This is the arrangement of ball mill. These are all the balls. I will show one video if possible. If it works. This is how balls are rotating. When the ball is rotating, the balls will fall like this. Due to this continuous motion, coal will crush and become small particles. So after becoming fine powder, this coal is transferred to the furnace with the help of air. That air is called as a primary air, so which carries the fuel to the furnace directly. So these are the internal components of the mill, ball tube mill. This is a screw conveyor which the coal to the ball tube mill. Through this screw conveyor, coal is fed from the outside and air is flows from the inside. Through this hollow pod, air goes inside the mill. That is a primary air and takes the fine particle and goes to the furnace directly. This is overview. From the ball tube mill, coal is fed horizontally in the both directions, and this mill is when the rotating, it forms into fine particles. So this fine particle again comes to this through this area and goes to the furnace directly. So this coal powder goes to the furnace with the help of primary air, which is produced with the fan. There are several fans in the boiler. So they are called primary air fan, PA fan, D fan, and ID fan. So PA fan purpose is to carry the fuel fine powder to the furnace directly. Fan, it is called forced draft fan. Its purpose is to supply the air to the furnace directly for complete combustion. Here it is another fan, induced draft fan, because it is a balanced draft boiler. Induced draft fan, so it is used for evacuating the flue gases from the furnace. It will install before the chimney. These are all PA fan, FD fan, and ID fan. These are the applications of fan. It is a FD fan. Here it is a fan. Here it is a ID fan. ID fan is installed after ESP. It is a boiler, throttle vertical boiler, and it is called as ESP. I will explain that. After ESP, this ID fan is installed, and these are the air heaters, because this FD fan, ID fan, or PA fan takes air from the atmosphere. It may contain some moisture also. So to remove that moisture, here air heaters, these are called air preheaters. Through with the help of air preheaters, this PA air and FD, that means primary and secondary airs are heated up. Here heating source is flue gas. Flue gas after economizer flows in one direction and air from the ID fan, FD fan and PA flows in other direction and get the heat from the flue gases. So these are all fans. And after that, it goes to boiler. Boilers are basically classified two types. All of you know this is a fire tube boilers and water tube boilers based on the media and based on the construction is single pass boiler and two pass boiler. So this is a basic type of water tube and fire boiler. In the water tube boiler, water flows inside the tube and flue gases flow over the tube. And in the fire tube boiler, flue gases flow into the tube and water surround the tube. So here in this major power plant, in any power plant, almost all power plants use the water tube boilers only. High pressure boilers are used water boilers only. And single pass and double pass boiler. This is a single pass boiler. That means only one pass from from the furnace to all superheater, economizer, reheater. Everything is installed in a vertical column. It is called as a single pass boiler. And another type of boiler is a double pass boiler. Here some heat exchangers are arranged here and some heat exchangers are arranged here. Only low temperature zone. The second pass is a low temperature. Here economizer are LTSH means low temperature superheater. This is called two pass boiler. In our 210 megawatts boiler, we are using both types of boilers. In unit 1, 2, there is the two pass boilers. And unit 3 to 6 single pass boiler. All are designed only. So this is a boiler furnace. It is called as a tangential fuel firing boiler. So from the four corners, directly fuel which is coming from the mill directly enters here. And initially we supply igniter here for igniting the fuel. And whatever the fuel coming through the tubes fire within 2.5 seconds. So as these are arranged tangentially, it forms like a ball. It is called as a fireball. It is arranged at the bottom of the furnace. Here it is a furnace which is arranged at the bottom of the furnace. So these flue gases flow vertically upward. So all heat exchangers are arranged in between. Heat exchanger means heaters, reheaters. All these heat exchangers are arranged in these paths. It is a two-pass boiler. So that these flue gases flows to the chimney through the ESPs. After ESP and chimney, there is a ID fan. It will extract the flue gases, and in between they arrange a flue gas.
Today's boilers, as they have been since their origin, involve the complex production and manipulation of steam.
These are all water tube boil.
The forced draft fan blows air into the system. A portion is routed to the pulverizers, which crush coal into a fine dust before pushing the mixture up through feeder tubes. The other portion passes through an air preheater, which transfers heat from the exhaust gases to the incoming air, raising the air temperature, reducing moisture, and producing a cleaner burn. The hot forced air and coal dust converge in the windbox, where the mixture is blown out through burners and ignited inside the firebox, transferring gradient heat to the water-filled tubes. The hot gases flow upward, heating the rest of the system through convection, before passing through the air preheater and ultimately flow into the scrubber where pollutants are removed. Liquid water is pumped into the system at the economizer. Gradually, it's heated to base temperature before gathering at the steam drum, the system's main distribution hub for circulating water and steam through the boiler. Liquid water flows through large tank-comers and into the base of the firebox. A network of 2-inch tubes line the firebox walls, and burners force feed a continuous supply of combustible fuel into the ultra-hot firebox. Eventually, the insides of the firebox burn so hot that its surrounding steel walls would melt if not for the tube-lined walls of liquid water. At the point in the cycle when the liquid water turns to
Like this,
steam,
all
the
heat
steam
exchangers
separates
are
and
here
collects
from
at
the
the
top
top of the
itself.
steam drum.
The
Because this
superheater
saturated
and
steam still
coil.
contains small amounts of liquid water that would cause corrosive damage to the turbine, the saturated steam is routed back into the...
Here, if you observe here, this is a boiler drum. In the boiler drum, 50% there is maintained and another 50% is for steam space. Initially, from the boiler feed pump, we supply water through the economizer to the boiler directly. This is the incoming line. So after coming here, water fills the boiler drum. These are called downcomers. Directly from the bottom, directly at the bottom of boiler drum, these are called downcomers. So through the downcomers, through gravity, directly water flows downwards. So after going downwards, it will go. There is a part called bottom ring header. That is at the bottommost point of the boiler furnace. So it will directly goes to the bottom ring header. From the bottom ring header, there is some riser tubes or water valves are found. Total furnace is covered with a number of tubes which are called water valves. So through the water valves, when it receives energy from the flue gases or furnace, so after getting heat energy, it will transform into water. It will not transform into water directly. This is what I am saying is about the 2 megawatt boiler. This is a subcritical boiler. It is called as a subcritical boiler. So water will not form directly into steam in a single stretch. It will take 7 turns to completely turn into steam. That is why it is called as a circulation ratio. Circulation ratio. So circulation ratio of this boiler is approximately 7. So it will take nearly 7 turns to completely turn into steam. So whatever the water turns into boiler steam, it will raise through the riser tubes due to density difference itself. When it gets the heat energy, temperature increase and density comes down and it will go upward. After going, it will reach to the boiler drum. After coming here, water steam are separated. So whatever the steam we are getting here is a dry saturated. That dry saturated steam is supplied superheater through the superheater. These are superheater lines. Superheater also a heat exchanger which is mounted inside the boiler.
Saturated steam is routed back into the firebox and through
So they are the
superheats to burn
overheater.
off all but the smallest traces of liquid water. This dry, superheated steam then exits the boiler, passing through a steam locker and ultimately providing power to the spinning turbine, which generates electricity. Finally, exhaust steam, now at a lower temperature and pressure, is sent back to the boiler through a dedicated reheat stage. This reusable steam is brought back up to operating temperature before returning to the turbine, providing additional power through a secondary stage.
Sir, this is the boiler. Next, these are the internal parts. All of you know this economizer. This is the purpose is to preheat the water before sending to the boiler drum. And superheater and reheater also heat exchangers to increase the efficiency of the boiler. For example, superheater are arranged after boiler drum. The saturated steam which is coming from the drum goes to the superheater and its temperature is at a constant pressure. So after getting its temperature, that steam, superheat steam is supplied to the turbine. In the turbine, it expands partially. After some intermediate pressure, the steam again comes back to the boiler, which is called a reheater. It is a modern Rankine cycle plant, that is, we are utilizing superheater and reheater and regeneration also. So in the reheater, at lower pressure, its temperature increase again and goes to the next turbine called intermediate pressure turbine or low pressure turbine. The water valves. Water valves are the valves surround the furnace. And desoper. The purpose of desoper is to reduce the temperature. For different utilities, low temperature and low pressure steam is required. For example, during fluid blowing or for ejector, all these purpose, low pressure, low temperature is required. For that purpose, desoperator. That means in the desoperator, they spray the feed water directly into the steam and reduce the temperature. Next, boiler is the main part of the boiler. There are different safety valves are arranged for the purpose. So this is the cross section of the entire boiler. These are water valves. These are all water valves. After water valves, this is a upper ring header. Goes to the this is a boiler drum. These are the downcomers. Through downcomers, water comes down, and through the water valves and risers goes to the boiler. This is the actual photograph of the boiler in this plant. This is boiler looks like this. Total insulation. There are hydro steps for measuring the level of in the boiler. There are the different lines, safety valves. Inside the boiler, these are the general arrangements. They call turbo separator, screen dryer for separating. For example, I already told the bottom half of the pot is filled with water, top half of the pot is filled with steam. In the steam, there is a chance of containing moisture. So that moisture is removed with the help of turbo separators and screen dryers. This is about the boiler system. This is a single pass boiler which I am showing here. So after boiling, in the boiler, what you are supplying? You are supplying air through the fan. That means through FD fan, forced draft fan. We are supplying coal powder, and we are supplying water to the drum. These are the three inputs to the boiler. So outputs are from the boiler drum. Steam is the one output. Ash. There are two types of ashes here: bottom ash and fly ash. So bottom is collected at the bottom of the boiler, and fly ash is collected at the ESP, which goes to the ESP through the flue gases. Flue gas is another output of the boiler. So when this flue gases goes to the chimney, it goes to the air preheater, which I already discussed. They are called air preheaters or regenerative air heat also. It is a heat exchanger that absorbs waste heat from the exhaust flue gas in the boiler and transfer to the heat to cold air. The cold air here we are using two types of air: primary air and secondary air. Primary air for transferring the fuel to the boiler, and secondary air is for complete combustion of the fuel inside the furnace. This is the location of the air preheater, which supplies the air to the furnace directly from the FD fan. The primary air is shown here in this diagram. After air preheater, flue gases enters to the ESP before going to the chimney. So this is the air preheater cross section. Here we have three sections. This is called the sector air heater. 30% pass is a flue gases, which is a hot source, and second 70% 30%. This part is it is 70 primary and secondary air. So flue gas flows from the to bottom. This is arrangement is made with baskets. Those are called baskets. it slowly rotates at 4 hours. So when it is rotating, for example, when it, in this condition, when flue gases flow through this basket, this basket receives the heat energy from the hot flue gases stored inside the basket. When this basket comes, because when it is rotating, when it comes here, cold gas flow over the basket. So this cold gas receives the energy from the basket and this temperature gain. For the primary air also flows through the basket. Okay, this is the cross section of the regenerative air preheater. Next one is ESP. Going one by one. After heater going to the ESP directly. The purpose of ESP is to remove the ash particles mixed with the flue gases. Electrostatic precipitator. ESP is an electrostatic precipitator. So it removes the suspended dust particles from the flue by applying high voltage electrostatic charge and collecting the particles and charged particles. So high voltage is generated inside the ESP. So these are two collectors, emitting electrode and receiving. There are two electrodes here. So when the flue gas flows through this flue, the heavy particles get ionized, and these positive ionized particles attract to the negative pole, negative ions to the positive pole, like this. So after attracting the bottom, there are some hammering arrangement is provided below the plate. So when hammering, it's done periodically. So when the hammer touches the plate, the heavy particles falls down. They collected in this bottom half. These are called bottom hoppers. That is why it is called as bottom hash. No, it actually fly ash, very lightweight particles, just like powder. This fly ash is evacuated with the help of vacuum system. This is a vacuum system, this is silo. Through this one, it is evacuated and sent out. Actually, this fly ash is used in cement industry mostly. There are this is sold out somewhere. Sometimes it will give freely also. So it's allocated with the help of tankers only, trucks and there are big lorries for carrying out this ash. So this is the ES system. A small This is how heavy particles are collected attached to the plate. This is a hammering arrangement. This is the evacuation of ash from the bottom. Bottom of this ESP. So after ESP through the ID fan, it will directly sent to the atmosphere. This is all about the bar and its main components. Next part is a turbine part. From the boiler drum, so dry saturated steam is supplied to the superheater. From the superheater, it goes to the turbine. So this is actually we have three turbines here. This is called high pressure turbine. It is a intermediate pressure turbine and it is a low pressure turbine. So this high pressure, the purpose of using many turbines is it is a compounding. Because to extract the energy available in the steam, if you use a single turbine, the rest of the turbine will be very big one. So it will cause some vibrations and maintenance operational problems also will occur. That is why we share the energy. That means we convert the energy in a number of stages in the number of turbines. So here we have in this design we have three turbines: HP turbine, IP turbine, and LP turbine. After going to the LP turbine, the steam goes to the condenser, comes back to the boiler. We will go one by one here. The turbine. These are all basics. No need to explain. This is the internal components. This is the cross section of the turbine. This part is called rotor, and the surrounding part is called as casing. This is called a casing. So in this turbine, steam enters at the center and flows in both directions. That is why it is called as a double flow turbine. The double flow turbine steam flow in both directions. So there is no problem with the balancing of the turbine. So it is a shaft, and this total shaft is taken by the two bearings. There are two bearings mounted on either side of the shaft. Okay. Here we have seen three turbines, HP, IP, and L turbines. All these turbines are coupled with the help of coupling. If you observe here, this is one row of blade. This is another row of blade. This is another row of blade. That's like that. There are number of rows of blades. Here also number of rows of blades. These blades are arranged on the rotor. That's why these blades are moving blades. In the same way, there is another row of blades in between the two row of blades in the casing also. That row of blade is called as a fixed blade. So fixed blades are arranged in a opposite direction to the moving blades. These are called blades. Those are called fixed blades. The size, shape, everything is same, but the direction is different. The main purpose of fixed blade is to change the direction of steam flow. Okay, these are basic components to know the further. So it is a cross section, it is a rotor, it is a casing. If you observe here, these blades are arranged on the rotor, which are called moving blades. In between, these are all the fixed blades, which are in the casing. It is a dummy piston. It is called as a piston. In case of single flow boiler, in case of single flow turbine, the dummy piston used because steam comes from the one end and flows along the axis of the blade. It means steam flow on the curved blade, but in axial direction. When it is moving in axial direction, some axial thrust also acts on the sub. So that due to that axial thrust, the piston may move towards leftward. For that part, to eliminate that one, nullify the axial thrust, one dummy piston is placed here. So some part of steam comes and hits back the dummy piston. So that force nullified. These are called bearings for supporting. The purpose of bearings is to support the turbine. These are the general classification of the steam turbine. Impulse reaction turbine. I am not going to solve these things. These are all basic things. Impulse and reaction, based on the principle of action of steam. In this plant, we are using, it is not a pure impulse or pure reaction turbine. It is a 50% reaction turbine. Initial stage first stage is the impulse stage. After one, it is a reaction turbine itself. So based on number of stages, as I told, the fixed blades and moving blades in the turbine. So one set of one fixed blade row and one moving blade row together called as a stage. One fixed row, one moving row blades is together is called as stage. So here in HP turbine we have 25 stages. If you take a I turbine, you have 20 plus 20, 4 stages. In LP turbine, you have only 8 plus 8 stages. Based on the steam flow classification is single flow and double flow. Single flow means steam enters one end and leaves for other end. Those are called single flow turbine. And steam enters at the middle and flows in both directions. That is called double flow turbine. So another classification is based on number of cylinders. Is single cylinder or multi-cylinder. That means in this 210 megawatt it is a 3-cylinder turbine. If you take 800 megawatts, they have 4 cylinders also. One high speed turbine, one IP turbine, and 2 low pressure turbines. Another classification is based on the direct steam flow. It is a axial flow or radial flow. Axial flow in the sense, if the steam flow is along the axis of the shaft, that is called as an axial flow turbine. If the steam flow across that means to the normal to the shaft, it is called radial flow. But power utility plants are of axial flow line. Based on the shaft arrangement. Shaft arrangement, tandem compounding, cross compounding. Here compounding means we learned compounding in another way. Pressure compounding, Wallace compounding, all these things. This is different compounding. This compounding is regard to the joining of the shaft. That means HP, IP, and LP shaft. All the shafts are arranged on a single line. That is called as a tandem compounding turbine. If these shafts are splitted into 2 lines, those are called cross compounding. Another one is based on the method of governing. Here, another governing is a very big topic actually. The purpose of governing is, in general, for mechanical engineers, we know that purpose of governing to maintain the constant speed. By varying the input, fuel input. Here also it maintains the way, but here it maintains the not only speed, it controls the frequency and it maintains the load also. So through 3 aspects. It controls the speed, load, and the frequency. So all these are done with the same effect, controlling the fuel itself. Here the fuel means, here we may not vary the fuel quickly, but we alter the steam inlet to the turbine. Here inlet is steam. By changing the steam inlet, the output is varied. For example, if the turbine speed is increasing gradually due to the load rejection. Load rejection means, for example, in the evening time, we switch on the lights, all fans, all these things, and that load will increase. So when the load is increasing, turbine speed comes down because due to increase of load. So this governing system detects the speed of the turbine and open the inlet valves of the turbine. So the turbine supplies more amount of steam inside the turbine. So the load can increase. In the similar way, when you switch off the lights or load will decrease on the grid. So when the load is decreasing, turbine speed will increase. So to normalize that speed, control valves close the steam input and bring back to the normalcy. In this power plant, turbine of the speed of the turbine is 3000 RPM. So we maintain almost 3000, try to maintain 3000 RPM. There are different types of governing, nozzle governing, throttle governing, and bypass governing. So different set of nozzles are used for control the steam input. That is called nozzle governing. Impulse turbines are used this nozzle governing. In impulse turbine, nozzle governing technique is used. In case of reaction turbine, this throttle governing is used. This throttle governing is just like our bike's acceleration or reduction. So here we have a control valve. So the control valve opens and closes as per the requirement. This bypass governing is used in combination with nozzle and throttle governing. This is used in nozzle governing and throttle governing also. This purpose of this bypass governing is for friction. That means it will attach to the first stage or second stage. So at the second stage, for example, if you quickly increase the load, this bypass governing valve opens and supplies steam directly at the second stage and quickly raise the load. Next one is based on the heat rejection. Heat rejection, the purpose of heat rejection is rejection done at the condenser. If we utilize the condenser, those are called condensing turbines. If we are not using the condenser, those are all non-condensing turbines. In case of textile industries or petrochemical industries, they need low pressure steam for process heat. In that case, steam from the turbine from last stages goes directly to the process heating, lower pressure. In that case, condenser is not required. But in thermal power plant, where the power generation is the only aspect, I use condenser only. There are so many advantages of condenser. We will discuss just the next one. So these are all about, in a simple way, we discussed about the turbine. Next, after going the turbine, next part is the condenser. These are all the, if you go to the Rankine cycle, this is the bottom horizontal line is the condenser. Okay. The purpose of condenser is to condense the steam and reutilize. To condense that steam is converted into water by removing the heat energy from the water, from the steam, and that condensed water is again reutilized for feed heating. That is the main purpose of the condenser. And another purpose is also there, that for improving the efficiency of the boiler. You can say how we can increase the efficiency. If you see if you observe the Rankine cycle, the method of increasing the cycle efficiency, you can reduce the condenser pressure, one option. Reducing the condenser pressure, increase the output. If you see the area of TS diagram, if you reduce the bottom line to the lower pressure, so the work done area will increase and heat rejection area will increase. In that way, cycle efficiency increase. That is another advantage of condenser. And we show some types of condenser here. Condenser is a closed vessel in which steam is condensed and vacuum is made. Vacuum is negative pressure. The output of the LP turbine is minus 0.9 kg per cm, minus 0.9 or 0.91 kg per cm square with the help of condenser. So in general, the condensers are of two types: jet condensers or surface condensers. In jet condenser, steam which is coming from the LP turbine is directly mixed with cold water. Cold water means already water. Okay. So when it is directly mixing, the heat energy is directly taken by the cold water. This is used for very small turbine where there is no use of this. There is reutilization of water. This jet condenser. But in surface condenser, it is a indirect contact type exchanger. Here there are a number of tubes. Water flows through the tubes. There are a number of tubes. If you take a condenser, in each pass there are 24. Each pass 12,000 tubes. Total 2 pass 24,000 tubes. Through the tubes, water will flow, and above the tubes, steam will fall. And the steam falls from the small tube. So cold heat Cold water extracts heat energy from the steam and it removes the latent heat. So it phase occurs here. There is no change in the temperature in the concept during heat transfer. So only phase change will occur. So steam is converted into water. So there are different functions also. This is a jet condenser. Steam exhaust is coming like this and is going up. Cooling water directly sprayed. These are called buffles. To slow down the process, these are called buffles. Mixture with the water. The main disadvantage of the jet condenser is we cannot reutilize this water, because if you want to reutilize this water, we have to supply DM water here. DM water is demineralized water. We supply demineralized water only to the bottom. We cannot use normal clarified water. This is a section of surface condenser. Through this small tube, water flow in both directions. It move like this and go out. It will flow from the top to bottom. This is at the bottom. This is one pass. It is called another two pass condenser. So water from cooling tower. There is another step here. Cooling tower technology, and there are some thermal power plants without cooling tower also. In our anti-TPS power plant, all six units are without cooling tower, because these are called one-screw system. One-screw system means there is no cooling tower. The water taken from the river. Here we have one pump house at the Bhavanipuram. From the Bhavanipuram, from the Krishna river, they take the water and supply to the power plant. That water is treated here. Treating means physical impurities are removed. That water is called clarified water, and that clarified water is supplied to the condenser. So this water extracts heat energy from the steam, and its temperature will rise. Water temperature rise, but there is no change in the temperature of steam. So this hot water again goes to the canal. If anybody knows Ibrahimbatnam, we observe two canals, one hot water canal and cold water canal. When you are going from Ibrahimbatnam to Vijayawada, first canal is the hot water canal. So this hot water canal directly flows to the ferry. There is a Sangamam area. That water directly goes to the river again. If the water is available abundantly, we use this one through system type of site. If the water is not available, and another disadvantage is the opening system. For example, in the summer season, the inlet temperature of water is very, and during winters or rainy season, the temperature of water is very low. So the efficiency of the condenser depends on the cooling water temperature. If the temperature is low, efficiency of the condenser is high because of the more condensation. But in case of summer season, the efficiency of condenser falls down by the ambient conditions. In case of cooling tower, the water which is coming out from the condenser sent back to the cooling tower. And again, cooling towers are two types basically, natural and artificial. Which if observe a very big cell, those are all natural cooling towers. So in that cooling tower, the water falls freely down. So atmospheric ambient air flows upward and removes the heat energy, and the cold water can supply back to the sensor. And this is the cooling tower. The water spray and the heat gas. These are artificial towers. These are artificial cooling towers. They run with the help of fans. These are all small size. The next one in the turbine circuit, this cycle, CEP. This is called as a condensate action pump, because here normal pump is, it cannot extract the water because the condensate also at a very low pressure because of vacuum. So this is CAP. This is a special pump which is having 7 stages of pump. It will extract water from the hot well. The bottom part is called the hot well. The water which is collected from the condenser is collected in the hot well. From the hot well, with the help of CEP, it supplies water up to D area. Up to this area, with the help of CEP, they will supply the CEP means condensate action pump. The purpose is to pump condensate from hot well to deaerator. It is a multi-stage pump. Each stage, the rise of pressure is 3 kg per cm square. So total 721 kg per cm square. It will raise the pressure up to 7. This is the total part. Up to this part is submerged in the ground itself. From that is hot up to hot well. It is an actual diagram of the CEP. This is a hole, big hole. The CEP is immersed in this hole. This is a ground floor in the power plant. So from the CEP, these are all small heat exchangers, small heat exchangers to improve the efficiency of the cycle. No need to discuss now. We cannot discuss. Already time is going up. Here, after from the CEP, it goes to deaerator through the heater. These are all heaters. There are types of heaters here: LP heater and H heater. LP heaters are low pressure heaters. HV heaters are high pressure heaters. The purpose of heating this water heating system in our Rankine cycle, we can say it is a regenerative water cycle. For heating this in this here, we take some amount of steam from the turbine, that is called bleeding steam, and we supply it to heaters. Again, there are two types of heaters here: direct mixing type, non-contact type, shell and tube type. This is a cross-section of the heaters, LP heaters and HP heaters. Both heaters have the similar construction. Water flows through the tubes. There are small tubes. Water flows through the tube like this and change the direction and goes down like this. This is the inlet. Water comes like this and flows like this, and again goes to outlet. This is the outlet. So this is the water circuit. So in this heater, it is a steam inlet. Steam from the turbine into the heater, and the steam directly falls over the tube, and this entire surface is filled. After filling, goes drain outlet. Actually, drain is provided at the middle. So what happens here? We take a low pressure steam from the turbine. Through the extraction, we take a low pressure steam. As a low pressure steam, once heat energy is removed from the steam, it will condense directly. The steam will condense, and that condensate is removed goes to the condenser again. It is a construction. Here are the tubes. It is a long tube. These tubes are arranged in this shell directly. Here are the arrangement of LP heaters. That means there are 3 heaters here. LP heater 1, 2, 3. Water flows from LP heater 1 to 2, 2 to 3. Okay. And steam. If you take a steam, this is extraction. Extraction steam comes to LP heater 3. The condensate is supplied by the LP heater 2 because its temperature is more than the alpha 2. Alpha 3 temperature is more than the alpha 2. So condensity is supplied back to the alpha 2 also. In the same way, the condensate from the alpha 2 is sent back to alpha 1. From the alpha 1, it sent back to the drain cooler. From drain cooler, it sent to the condenser. This is a construction of HP heaters. So these are LP heaters. From the it goes to the deaerator. Deaerator is deaerator. The name itself is deaeration. Aeration means to remove the condensable gases. Here, in the condenser, remove non-condensable gases with the help of ejector. It is not shown here. There are some ejects called. If you observe here, there is a main air ejector after the CAP. The main air ejector. The purpose of main air ejector is to remove the non-condensable gases from the condenser. Here, we remove the condensable gases because in the water some gases are mixed. So this condensable gases are removed in the deaerator with the help of two concepts. One is chemical deaeration, another one thermal deaeration. In the chemical, mix a chemical, some chemicals like ammonia in tank. So due to chemical reaction, so condensable gases are escaped from the feed water. Another one is thermal deaeration. Thermal deaeration means to increase the temperature by using steam. Here also some amount of steam taken from the turbine and sent to the deaerator where it's mixed with the water and its temperature increases. So solubility of gases decreases as the temperature increases. So when the temperature of the feed water increases, gases are automatically escape from the deaerator. Actually, in the thermal power plant, the deaerator is placed in the 16-meter. That means actually the thermal power plant different floor measure in terms of meters. For example, in 0 meter, some equipment are placed. Boiler feed pump, boiler feed pumps are placed in 0 meters. Next stage is 5 meters. Elevators are placed in the 5 meters. Next stage is 15. These are HP heaters and all turbines, generators, all these things installed in a 10 meters. Next one is 16 meters. In the 16 meters, deaerator and some more equipment are installed. Because that means from boiler feed to deaerator, there is a height of 16 meters. So because of this height, it creates some suction head at the feed pump because to avoid gravitation problem. Next one, so I will show the deaerator. The purpose of deaerator is to remove the dissolved oxygen and other gases to heat feed water. Mix the water and steam in controlled manner. Protects boiler components from corrosion by removing gases. If gas is exist in the water, corrosion will occur inside the boiler. Actually, this top part is the deaerator and it is a storage tank. It is called as a feed water storage tank. This is the method of feed water heating in the deaerator and removing the gases. So after deaerator, it goes to the through the LP heaters, it goes to the boiler again. So this is the overall stuff. I will discuss about the simple Rankine cycle here. What is the input and what is the heat transfer. So here is the main mechanism. The purpose of this turbine is convert heat energy into mechanical energy. That mechanical energy is given to the generator for rotation, for rotating the shaft of the generator. So this is the main our topic, generator. The generator. So it is again simple base definition. The machine which converts mechanical energy into electrical energy. It's based on two principles. Same Faraday's law principle only. So it consists of basically two parts, stator and rotor. One is a rotating part and another is a stator. It is a stator part which is having all windings here. It is a rotor part. So it is a two-pole generator here in 210 megawatts two-pole generator. If you observe, there are two fans here, two fans. So a generator principle is not our concept here. Inside, when it is rotating, when the shaft is rotating inside the stator, huge amount of heat is generated inside the generator. So that heat is to be removed from the generator. Here, hydrogen. Main purpose of hydrogen is for cooling the hydrogen core. This is the core. It is called as a core. So for cooling the core, use the hydrogen. And after receiving the energy from this part, hydrogen temperature will also increase. So that heat is removed with the help of water cooler. So the purpose of hydrogen in this in thermal power plant basically for cooling of the generator. The generator cooling system is hydrogen and gas to transfer heat from the generator to parts, such as rotor, stator, and into water cooler. Hydrogen is good coolant because it has a high heat capacity and low density, making it 7 times more effective at transferring it than air. It is 7 times more effective than air. So, when you come to the hydrogen flammability range, hydrogen is a very dangerous gas because it's a wide range of flammability. If you observe this diagram, 4% to 7%. 4% to 70% hydrogen mixed in the air, it will catch fire. Below 4% or above 4%, it is not flammable. It will not take energy. Right? That is why in the hydrogen, in the generator core, they use more than 80% hydrogen. They maintain more than 80% concentration in the hydro core. So it is a simplest and most abundant element in the universe. Physical properties are colorless, odor and tasteless, highly inflammable and lighter than low density. And one more thing, its flame is also not visible. We cannot visit. It is see the hydrogen flame with naked eye. That is the main problem. We cannot observe that there is a hydrogen flame also. Next, chemical properties combine with oxygen to form H2O. Reacts with metals. This is so. As per the requirements of our plant, we generate hydrogen in our plant system. This is the hydrogen plant in our plant premises. Hydrogen. Here we are using. I am not going to chem process or about the generation of the chemical. Just going through the what kind of method we are using and application of green energy like this one. This is the hydrogen plant. Inside, this is the ACT process. It is called electrolyzer. It is the electrolyzer, and these are all the subsequent. This for this electrolyte, this is the input. Here they called lye. They are called it lye. In this, they mix the water with AOH and other chemicals. This chemical compound is sent to the electrolyzer. Here, in this O2 and H2 are separated here in this frequent equipment, and O2 is directly sent to the atmosphere and H2 is collected. It is called as chiller unit. Which, they maintain the cooling in the equipment. It is a rectifier. The purpose of rectifier is to run the electrolyzer. Our main concept is here also. It is a main input. That means power source is a DC. For this electrolyte, DC power is the main input. These are all of. So from the output, the gas is collected in the buffer tank. This tank is a buffer tank. In this tank, the approximate H2 pressure is 20 kg per cm square only. After this, it is a compressor. In this compressor, H2 is compressed and directly sent to the filling unit. It is filling unit outside. They directly fill in the cylinder and store. It is a hydrogen storing area. This is schematic diagram. And comes to the green hydrogen or green hydrogen. The main difference of hydrogen, green hydrogen is power supply mechanism. There are so many colors of hydrogen are there. All are depends on the type of power, what power you are using. So here we have green energy, renewable electricity. That means solar, hydel or wind. From any energy, if you supply power to the electricity process, that is called as a green hydrogen. That means if we in our plant, if we supply the power we are supplying to the electrolyte, if you supply renewable energy, that is called as a green energy. What is green hydrogen is, I think you are all familiar because everybody is explaining about this hydrogen for the last few days. So my motto is go with the thermal power plant and its application only. These are the main features. This one, zero carbon and sustainable and clean energy source. How is a zero carbon emission is when you are generating hydrogen with a different method, it releases some CO2 into the atmosphere. But in the electrolysis process, the hydrogen production will not generate CO2. That is why it is a clean energy. That is why it is a very important. And why it is important? It is energy storage. Hydrogen can store and use it when renewable energy production is low. But it is in gaseous state. Hydrogen can be stored in a liquid state if you require. Next, application of hydrogen. These are the general application, energy storage. Nowadays, we observe some hydrogen buses and trains. So these are all the options of hydrogen in the transport section. And industrial use, using steel production, ammonia production, and chemical manufacturing. And with in case of a thermal power plant, cooling of the generator is the main purpose of hydrogen. And another main concept of hydrogen is they are using as a co-firing also directly in the turbines. They are trying to directly use in the gas turbines for firing and generating power. Okay, next global green energy initiative. Countries leading in green hydrogen: Germany, Australia, all countries leading. And in India also, national green hydrogen is started. They are allocating some this amount of budget for all purposes, for site program, for pilot project, for R&D purpose, towards the mission components. Nowadays we are also trying to expand the green energy. Recently in Visakhapatnam, with collaborated with NTPC, they are trying to start a green energy, green hydrogen manufacturing. So the future of hydrogen is green hydrogen market is expected to grow exponentially in the upcoming decades. key role in achieving non-zero emission by 2050. This is the main question. So for this, improvements in electrolyzer efficiency and the materials for energy storage are required. These are the technological innovations required for this one, and integration with other renewables. So overall, where the main attention required on the attention is, it offers a clean, sustainable energy solution for the future. Despite the challenges, it has a vast potential in decarbonization. That means it reduces the carbon emissions. And the main attention point is support policies, investments, and research in green hydrogen technologies for cleaner and more sustainable world. For this one, we require support from the government and other sectors also, because it is a costly one compared with the natural. So main benefits are no CO emissions during the process. It reduces reliance on fossil fuels and helps diversity energy sources. And job creation also. New industries, job opportunities in the renewable energy and hydrogen sector. Because, for example, let us say in our plant, in our thermal power plant, as we are generating energy, we are simply using that energy in the electrolysis process. If we want to apply this hydrogen technology for generation of hydrogen, we have to generate green energy. Means we have to use solar panels, or in this area solar is only possible because wind is not possible because wind speed, and hydel is not possible. But for solar energy, we need huge amount of area, wide area. We need wide area for installation of solar panels for getting solar energy. So that increases the cost of production. That increases the cost of production of the power here. So that is the main drawback here for applying the green hydrogen technology in this existing thermal power plant. We are remaining all these things are already discussed. So I think I covered as per your requirement. Any questions? Please go through.
Thank you, sir.
Sir.
Thank you so much for your presentation on working of thermal power plants, and also the importance of green hydrogen and its application in thermal power plants and cooling of gas turbine blades. Dear participants, any queries? Dear participants, any queries?
Thank you, sir, for your wonderful session. Thank you so much, sir.
Thank you very much, sir. I'm sorry for the inconvenience at the starting of the session.
Sir, excuse me, sir.
Nothing, sir.
Participant number 139, he raised his hand, sir.
What is that?
There is a question raised from participant 139. Sir, please unmute your audio and you can raise your query. Any queries from? Hello, sir.
What is the question, sir?
Just raise the hand only.
Prasad sir.
Sir.
Thank you, sir. Thank you for delivering a nice talk to our participants.
Hello, sir.
Sir, please switch on your video, sir. along with participants.
Sir is already in. Sir is already in video mode only.
Okay.
So all the participants
Hello,
just
sir.
switch on video.
Hello, sir.
Sir, tell me.
Sir, I have one doubt for.
Tell me.
Sir, is it electrolysis technique? Is it a futuristic technique compared to the thermal plant?
Pardon? This is actually electrolysis technique is the best one because there is no emission of CO2 in this electrolysis process. The main difference of green hydrogen and generally input power.
Sir, main reason in the electrolysis technique is the anode and cathode.
Yes.
To making an anode and cathode, is it a expensive technique? So it is it's called the futurist technique or not? Simple.
No, it is a futurist technique because in future the main aim is to reduce the emissions is the main technique. Even if the cost, to increase the cost also, our main aim is to reduce the emissions, to reduce the global warming. That is the main motto. Main future aim is even in the power plants also, we are going for many new advancements, even if power of the generation increases to reduce the emissions.
Okay, sir. Thank you, sir.
Participant, please switch on your videos. All of you, please switch on your videos fastly.
Vishwanath sir.
Sir.
Vishwanath sir. Meanwhile, you can share the feedback link in Teams as well as WhatsApp group.
Yes, sir.
Okay, thank you. So, dear participants, please. So, dear participants, please fill the feedback link of third day. We will share in the WhatsApp group as well as Teams. So, thank you one and all.
Thank you, sir.
Thank you, Prasad sir.
Sir, thank you.
Thank you very much, sir.
Thank you very much for giving this opportunity.